and should understand clearly how every part of the generator works and so be able to perform maintenance if that should ever prove to be necessary. James Hardy's self-powered water pump generator. There is a video on Google which shows an interesting self-powered water pump driven electrical generator at http://www.youtube.com/watch?v=IGPXA6QHH_Q. This is a very simple device where the jet of water from the pump is directed at a simple water wheel which in turn spins an electrical alternator, powering both the pump and an electric light bulb, demonstrating free energy. Initially, the generator is got up to speed, driven by the mains electrical supply. Then, when it is running normally, the mains connection is removed and the motor/generator sustains itself and is also able to power at least one light bulb. The generator output is normal mains current from a standard off-the-shelf alternator. James has patent application US 2007/00184661A1 published in 2007 on his design. In that application he points out that a major advantage of his design is the low noise level produced when the generator is running. In the video and the pictures above, the demonstration has the housing opened up in order to show how the generator system works, but during normal use, the compartments are completely sealed. In his document, James shows the overall system like this. The housing is divided into 3 separate compartments. The first compartment has a strong axle shaft running through it, supported on ball or roller bearings, possibly ceramic for this environment. The bearings are protected by being covered by splash guards which keep the water, or other liquid, off them. A water wheel of almost any type is mounted on the shaft and a high-capacity water pump directs a stream of liquid onto the water wheel, striking the paddles at right angles in order to provide the maximum impact. This first compartment is sealed in order to contain all of the liquid inside it, and the bottom is effectively a sump for the liquid. A pipe located near the bottom of the compartment feeds the liquid to the pump which is located in the second compartment. The pump boosts the liquid through a nozzle, directing it at the water wheel. While almost any nozzle will work, it is usual to choose one which produces a concentrated jet of liquid in order to generate the largest possible impact. One would expect that the larger the diameter of the water wheel, the more powerful the system would be. However, that is not necessarily the case, as other factors such as the overall weight of the rotating members might affect the performance. Experimentation should show the most effective combination for any given pump. The rotating shaft is given a third bearing supported by the side of the final compartment. The shaft then has a large diameter belt pulley mounted on it, the belt driving a much smaller pulley mounted on the shaft of the generator. This raises the rate at which the generator shaft is rotated. If the pump operates on AC mains voltage, then the generator will be one which generates mains voltage AC. If the pump operates on, say, 12 volts, then the generator will be one which generates 12 volts DC. The diagram above shows the arrangement for a mains voltage system, as that is probably the most convenient. If a 12-volt system is chosen, then the inverter can be omitted. The generator is started by pressing the normally open press button switch marked A in the diagram. This passes the battery power through to the 1 kW inverter, which then generates AC mains voltage. The switch marked B is a changeover switch, and for starting, it is set so that it passes the AC power through switch A to the pump. This causes the pump to turn on and direct a powerful jet of liquid at the water wheel, forcing it around and so powering the generator. When the generator gets up to full speed, switch B is flipped over, disconnecting the inverter and feeding the generator power through to the pump, keeping it running and supplying additional power to the output power sockets mounted on top of the housing. The press button switch is released, disconnecting the battery which is no longer needed. Switch C is an ordinary on/off mains switch which is needed if you want to turn the generator off. A major advantage of this generator system is that the main components can be bought ready-made, and so only very simple constructional skills and readily available materials are needed. Another advantage is that what is happening can be seen. If the pump is not working, then it is a simple task to discover why. If the generator is not spinning, then you can see that and sort the problem. Every component is simple and straightforward. James suggests that a suitable pump is the 10,000 gallons per hour torpedo pump from Calpump. Website, http://www.calpumpstore.com/products/product details/part_number =T1000/416.0.1.1. Rahul Hadam's magnetic coupling system. Generally, the rotoverter has very low input power when not loaded and about a 90% energy reduction when under load. The ideal situation is where there is a constant load, as the tuning of the rotoverter does depend to some degree on the load. However, the rotoverter performance can be increased very substantially by using the techniques introduced by Rahul Hadam in 1955, which conventional science will not accept because according to current theory, any such energy gain has to be impossible and so, cannot happen no matter what evidence there is. Rahul Hadam's heretical statement is that using spinning magnets draws in energy from the environment, allowing a system to have COP1. His method is to use a motor, whether rotoverter or not, to spin a heavy rotor disc with 36 powerful rare earth magnets mounted on it. Then, using an identical heavy disc with magnets mounted on a generator to give a magnetic coupling between the motor and the generator can give not just coupling, but an energy gain as well, an energy gain which Hadam says is 20 times. The heavy rotor provides some flywheel effect which helps with the operation of the system. Even with one motor as shown above, there is an energy gain as demonstrated in a recent video demonstration of the effect at http://www.dailymotion.com/video/xi9s9b_motor-magneti-q-d-lean-UAGVTCR6 BO, where a simple system produces 144 watts of excess power. However, the really big gains are got when several generators are driven by just the one motor. In passing, it may be remarked that there are two separate energy gain systems operating here. Firstly, the rotating magnetic field acts directly on the excess electrons in the local environment, drawing them into the system just as the fluctuating magnetic field of the secondary winding of any transformer does. Secondly, the rotors are receiving a rapid stream of drive pulses, and as Chas Campbell has demonstrated, that draws in excess energy from the gravitational field. Anyway, you will notice that the powerful magnets used have their north poles outwards on one rotor while the adjacent rotor has the south poles outwards. The very strong attraction between these opposite poles cause the generator disc to rotate in step with the motor disc. This process allows many generators to be driven by just the one motor as shown here and in the photograph above. For ease of drawing, the diagram above shows only 8 magnets per rotor disc, but you will notice in the photograph, and in the video, that there are 3 stepped rows of magnets on each rotor. You will also notice that direction of the stepping is reversed on every second rotor disc in order for the magnets to match each other in position as they rotate in opposite directions. The relevant patent on this is FR 2,826,800 of January 2003. Hadam has an interesting video at https://www.youtube.com/watchv=3ujz9hkna and ebk=3vksbvw2e9ozophagy_tYOSB. Bmuft 5zz88 highitly yulnev jalozus 6 hulagat 2. Lawrence Seung's cop =33 pulsed flywheel. Lawrence has been presenting his theory of lead-out energy, which indicates that excess energy is drawn from the environment when there is an impact. The method of producing this effect which he has followed is to create an unbalanced wheel and demonstrate that excess energy is produced. It should be stressed that energy is never created or destroyed, and so, when he measures more energy in his device than the energy which he uses to power it, energy is not being created but is instead being drawn in from the local environment. Lawrence has recently demonstrated a prototype to members of the public. This simple device was demonstrated to have 3.3 times as much output power as the input power needed to make it operate. This is an early prototype which was demonstrated in October 2009, and Lawrence and his helpers are working on to produce more advanced models which have kilowatts of excess electrical power. Mr. Xiong remarks, the Li-Xiong lead-out energy theory was first disclosed to the world on December 20, 2004 at Tai-Po, in Hong Kong. The lead-out energy theory basically says that one can lead out, or bring in, energy from the surrounding environment into a lead-out energy machine. The total input energy is equal to the sum of the supplied energy plus the lead-out energy. For example, if the supplied energy is 100 units and the lead-out energy is 50 units, the device's total input energy will be 150 units. This means that the output energy can be more than the supplied energy of 100 units provided by the person using the device. If we ignore the small loss of energy caused by less than 100% efficiency of the device itself, then the output energy will be the whole of the 150 units. If we use 50 of the output energy units and feed back 100 of the output units as the supplied energy, then that supplied energy can again lead out another 50 units of excess output energy for us to use. Thus a lead-out energy machine can continuously lead out pollution-free, virtually inexhaustible and readily available energy for us to use. We do not need to burn any fossil fuel or pollute our environment. The two examples of lead-out energy which we access are gravitational and electron motion energy. The lead-out energy theory does not violate the law of conservation of energy. The law of conservation of energy has been used as a roadblock for the so-called over-unity devices. The patent offices and the scientific establishment routinely dismiss an invention as belonging to the impossible perpetual motion machine category if the inventor cannot identify the energy source of his invention. We got the help of Mr. Tong Po Chi to produce a 60 cm diameter lead-out energy machine in October 2009. The output energy of that device is greater than the input energy by a factor of 3 times. These results are confirmed by voltmeters and ammeters measuring the input and output energies. The Tong wheel has been shown at 2 open shows in Hong Kong, Inno Carnival 2009 and Inno Design Tech Expo, in November and December 2009. Over 25,000 people have seen it. The Better Hong Kong radio show has video recorded it, the discussions being conducted in Chinese. At this time, the Tong wheel is at the radio studio available for experts to view and examine with their own instruments. The Tong wheel has a diameter of 600 mm and this large size is considered to be important. It has 16 permanent magnets mounted on its rim and 15 air core coils mounted around it on the stator. There is one position sensor. The coils can be switched to act as drive coils or as energy collection coils. With this arrangement, if the positions the switches as shown for 10 of the 15 coils shown here, then they act as drive coils. The sensor is adjusted so that the drive circuit delivers a brief energizing pulse to those coils just after the magnets have passed their exact alignment position with the coils. This causes them to generate a magnetic field which repels the magnets, thrusting the rotor around. The pulse is very brief, so very little power is needed to accomplish this pulsing. As mentioned before, any number of coils can be switched to provide this driving force. With this particular wheel construction by Mr. Tong, the best number has been found to be 10 drive coils. The power pickup is achieved by gathering the electricity generated in some of the coils as the magnets move past them. In this particular arrangement, 5 of the coils gather energy while 10 provide the drive. For the sake of simplicity, the diagram shows the 5 collection coils adjacent to each other, and while that would work, the wheel is better balanced if the drive coils are evenly spaced out around the rim. For that reason, this switching would actually be selected to give 5 sets of 2 drive coils followed by 1 pickup coil, as that gives a perfectly balanced thrust on the wheel. The 2 diagrams above are shown separately in order to make it clear how the drive switching and the power pickup switching are arranged. The full design arrangement and the balanced switching are shown in the following diagram, which indicates how the full design is implemented on this particular implementation of the wheel design. The sensor can be a coil feeding a semiconductor switching circuit, or it can be a magnetic semiconductor called a Hall effect device which can also feed a semiconductor circuit. An alternative would be a reed switch, which is a simple mechanical switch encased in an inert gas inside a tiny glass envelope. Suitable switching circuits are described and explained in Chapter 12 of this e-book. Mr. Tsiung remarks that the large wheel size is due to the fact that the pulse force takes time to impart the impulse to the wheel and lead out energy from the environment into the system. If you want to see this actual wheel, you can email Dr. Alexandra Yuan at ayuan@hkstar.com to make an appointment. The Tong wheel is located at the Better Hong Kong Radio Studio in Causeway Bay, Hong Kong. Just say that you want to see the lead-out energy machine. The demonstration can be in English or in Chinese. Ideally, there should be a group of at least 6 visitors, with one or more being a qualified engineer or scientist, and you are welcome to bring your own cameras and or test equipment. It is planned to produce a version which has a 300-watt output, and another with a 5 kilowatt output. Educational kits are also planned. If you decide to replicate this particular design, then to raise the output power level you might consider putting another set of coils around the wheel and either using them as 15 additional energy pickup coils, or alternatively, pulsing the wheel twice as often. Adding one or more additional rotor discs to the same rotating shaft is also an option, and that has the advantage of increasing the rotor weight and improving the effect of the impulses on the rotor. The diameter of the wire used to wind the coils is a design choice which has a wide scope. The thicker the wire, the greater the current and the larger the impulse given to the wheel. The coils are normally connected in parallel as shown in the diagrams. Because of the way magnetic field strength drops off with the square of the distance, it is generally considered good design practice to make the coils 1.5 times as wide as they are deep, as indicated in the diagrams above, but this is not a critical factor. This design is, of course, a version of the Adams motor described at the start of this chapter. Although motors of this kind can be built in many different ways, the construction used by Mr. Tong has some distinct advantages, so here is a little more detail on how I understand the construction to be carried out. There are 2 side pieces which are attached together by 16 cross timbers, each of which are held in place by 2 screws at each end. This produces a rigid structure, while the construction method is as simple as is possible, using readily available materials which are worked with the most basic of hand tools. The construction also allows the motor to be taken apart completely without any difficulty, transported as a flat pack package and then assembled at a new location. It also facilitates people who want to see the motor taken apart after a demonstration in order to assure themselves that there is no hidden power source. Each of the cross timbers provide a secure mounting platform for an electromagnet and its associated switch. In the implementation by Mr. Tong, there appears to be just the one rotor, configured as shown above, with 16 permanent magnets mounted in its rim. The magnetic poles of these magnets are all orientated in the same direction. That is to say, the magnetic poles facing outwards are all either south or all north poles. It is not critical whether the outward-facing poles are north or south, as Robert Adams used both arrangements with great success, but having said that, most people prefer to have the north poles facing outwards. Robert has always said that one rotor was enough, but his techniques were so sophisticated that he was able to extract kilowatts of excess power from a single small rotor. For us, just starting to experiment and test a motor of this type, it seems sensible to stick with what Mr. Tong has experienced success. However, this build by Mr. Tong is not his final motor but just one in a series of continuously improved motors. The following diagram shows an arrangement which has 3 rotors attached to a single shaft, and while you may choose to construct this with just one rotor, if the cross timbers are long enough, then 1 or 2 extra rotors can be added in very easily at a later date. Here, just 2 of the cross timbers are shown. The electromagnet coils used by Mr. Tong are air core, as that type have the least effect on the passing magnets. However, electromagnets with cores tend to be much more power for any given current flowing through them. In theory, the core should be made of lengths of insulated iron wire, as that would reduce power loss through eddy currents flowing in the core, but Robert actually recommends solid metal cores, and as he was the most experienced person in this field, paying attention to what he said seems sensible. The core material needs to be a metal which magnetizes easily and powerfully, but which does not retain any of its magnetism when the current stops flowing. Not many metals have those characteristics, and soft iron is usually recommended. Nowadays, soft iron is not always readily available, and so a convenient alternative is the central bolt of a masonry anchor, which has excellent properties. The shaft of the bolt can be cut quite easily with a hacksaw, but be sure to remove, or file down, the head of the bolt, as the increase in diameter has a marked effect on the magnetic properties of the electromagnet core if it is left in place. The bolt shown above is a M16X 147 mm masonry anchor bolt with a bolt diameter of 10 mm. Some makes of drying felt whiteboard markers have a rigid body which fits the 10 mm bolt exactly and provide an excellent tube for constructing an electromagnet bobbin. With a core in the electromagnets, the rotor gets additional rotating power. Initially, the magnets on the rotor are attracted to the electromagnet cores, giving the rotor a turning force which does not require any current to be supplied. When the rotor magnets are at their closest point to the electromagnet cores, the windings are powered up briefly, and that gives the rotor magnets a strong push away, causing the rotor to spin. There are many different designs of simple drive circuits, and it is probably worth trying out different types to see which works best with your particular build of motor. In the same way, there are many kinds of collection circuits for taking off some of the excess power generated. The most simple of these is just a diode bridge, perhaps feeding a battery and charging it up for use at a later time. If you get sophisticated with the collection circuit and just take power off for a very short period of time at the correct moment, the cutting off of the current draw causes a back EMF magnetic pulse in the collection electromagnet, which causes it to give the rotor an extra drive push, both current collection and rotor drive in one combined package. Here are two of the most simple circuits possible, one for drive and one for power collection. The drive circuit transistor is switched on by a voltage generated in the gray coil by a rotor magnet passing by. The transistor then feeds a large current pulse to the black coil, driving the rotor on its way. The neon and the diode are there to protect the transistor, and a physical layout for the circuit might be: the 1K variable resistor is adjusted to give the best performance, and the on/off switch is optional. More advanced circuits, such as the one on page 2 to 9, can also be tried and the performance compared. Generally speaking, I would expect a 3-rotor version to give a better performance than a single rotor implementation, but experimentation is needed. DC motor efficiency. Commercially available DC motors are deliberately designed and manufactured to have extremely poor performance. In my opinion, the reason for this is that a properly designed electric motor could easily do away with the need for using internal combustion engines in vehicles, and that would not suit the oil companies or their owners, the New World Order cartels. Worse still, electric motors with COP1 open the way to self-powered free energy systems, and that would never do. The video, http://torrent-db.in/95d95cff2bbc8039ed/peter-lindemann-electric-motor-secrets.torrent, is available on the web, and I strongly recommend that you watch all of it. It presents the basic facts very nicely. In brief outline, present-day motors act both as a motor and as a generator of electrical power, but they are deliberately wound so that the power generation is used to oppose the input power and so produce a completely crippled output. During World War II, a German engineer rewired a standard electric motor and made it self-powered, that is, it ran and produced mechanical output power without the need for any input power once it had been started. That shows the potential of a properly constructed electric motor with the same size and general structure of any commercial electric motor. Presumably, he did that by adding extra brushes and using some of the windings in generator mode with their output powering the drive windings, which were arranged asymmetrically. There was also one other man who achieved self-powered rewiring of a motor, but neither of those men made their information public knowledge. The con job which has been run on us for many decades now is to wind the motor in such as way that the magnetic fields inside the motor oppose each other. When a current is passed through a coil of wire, it stores energy in that coil, and when the current flow is cut off, that energy needs to flow back out of the coil, and it will do so in the reverse direction. This is sometimes called back EMF, electromotive force, although many people are not happy with that description. However, no matter what you call it, there is energy stored in the coil, and that energy can be used to do useful work. But, the motor manufacturers choose to wind the motor so that instead of extracting that useful power, they use it to oppose a major part of the input power, creating a weak motor which heats up due to the wasted energy. Contributor UF Politics points out that a deliberate misdesign of electric motors has, for the last 130 years, been presented to us as the only way to make and operate such motors. He states that because the windings are arranged in a symmetrical way, that a braking effect is produced which reduces the output power of the motor by anything from 50% to 90%. That is, a properly wound motor would have anything from twice to 10 times the output power for the same input power. This misdesign guarantees that present-day motors are always less than 100% efficient and always heat up when run. This misdesign is caused by using symmetrical windings in the motor. Standard motor wiring is quite different, and the killer effect is caused by having two windings which face each other, powered simultaneously with currents flowing in opposite directions. This causes a complete conflict between the magnetic fields, and that destroys the efficiency of the motor. A very experienced experimenter has started a forum thread on the Energetic Forum, both to explain this and to show new and more advanced construction methods, and to answer questions and encourage replications and further developments. The forum is at http://www.energeticforum.com/renewableenergy/11885-my-electrodynamic-machines.html, and is definitely worth visiting, especially if you are good with mechanical devices. The experimenter uses the forum ID of UF Politics, and he has produced an animated video in an attempt to explain the basic problems with present-day DC electric motors. http://www.youtube.com/watch?v=mj4rv0ae-q& feature =channel =list =ul. He points out that a problem winding in the standard DC motor looks like this. The input current for any winding is fed in through a single pair of brush contacts. The generated electrical power EC is not extracted and is forced to oppose the input energy EA, leaving only a fraction of the input power to actually run the motor. It is likely that a motor of this type will only operate at 25% of its potential efficiency. UF Politics has produced and demonstrated a simple way of overcoming this problem while using the existing motor housing, magnets and brush contacts. He does this by extracting the generated electrical power as a useful output, and so preventing that useful power being used against the motor's operation. To implement this, he adds one additional pair of brushes and rewinds the motor coils like this. Here, one pair of brushes is at the top and one pair at the bottom of the armature, the bit that rotates inside the motor housing and provides the mechanical power output. The coils are rewound to form a series of separate vertical coils, connecting to one brush terminal at the top and one brush terminal at the bottom as shown above. The input power is between the terminals on the left and flows through the coil shown in brown. The current flow generates a magnetic field, causing rotation because of the permanent magnets marked N, for a magnet which has its north pole facing the coils, and S, for a magnet which has its south pole facing the coils. The black zigzag line represents the resistance to current flow of the wire and brush contacts. The coil shown in green on the right represents that same coil at a later moment when it has been disconnected from the power supply and rotated until it reaches that position, at which point, the energy stored in it is taken off as a useful output via the right-hand pair of brushes. However, This is just an explanatory diagram and it does not show the very important fact that the discharging coil must not directly face a driving coil, because if it does, then the energy discharge would create a magnetic field which would interfere with the magnetic field of the driving coil and create a major problem. Right, to say that again, any one coil is powered on the left-hand side to drive the armature around and provide the output shaft with turning power, torque. Then that rotation disconnects that coil from the input power, leaving the coil charged with energy which has nowhere to go. That charged coil continues round until it hits the second set of brushes, which allow it to discharge through a load and do useful work. The really clever part of the adaptation of the motor is best seen from above the vertical rotor. If, for example, you were to take a 5-pole DC motor apart and remove the windings, the shaft and armature body might look like this. When making an asymmetrical wound rotor, the windings go like this. The start of the wire is secured at the top and then fed downwards through the opening A and back up through the opening B. For the small Radio Shack motor, this winding would be 25 turns of number 30 AWG wire, described as Radio Shack red wire, with a copper wire diameter of 0.255 mm. If you are rewinding a motor armature, please understand that each wire turn needs to be pulled tight in order to make a tight, solid and robust coil which will not vibrate unduly when the armature is spinning. The end of the wire marked finish is not cut, but is taken down through opening A and this time, up through opening C. For clarity, these continuing turns are shown in a different color, but please realize that it is the same single strand of wire being used throughout. The final wire turn goes down through opening A and finishes at the other end of the body of the armature. In these views, the wire runs down into the paper, each turn forming a cylinder. This view may give you a better visual picture of what the coils are wound on. The next step is to connect the start and finish wire ends of this V-shaped double coil to the commutator slip rings which allow current to be passed through the coil at just the right moment. Seen again from one end of the armature, the connections are like this. The commutator slip rings are connected further up on the drive shaft and the start of the winding wire, shown previously in dark green, is connected to the top commutator sector in the position shown here. The finishing end of the wire is connected to the corresponding commutator sector at the far end of the shaft, that is, the sector directly in line with the upper sector just connected to the start of the wire. This completes the first of 5 identical V-shaped coils. The next coil is wound in the same way. The armature is rotated one sector counterclockwise so that sector D replaces A at the top, and the next coil is wound with the wire starting at the top and going down through opening D and up through opening E, repeating the same number of turns, and then, without cutting the wire, the next set of wires are wound going down through opening D and back up through opening F. The start of the wire is then connected to the commutator sector which spans between openings A and E, and the end connected to the corresponding commutator sector at the other end of the shaft. For each of the remaining 3 windings, the shaft is rotated one position counterclockwise and the same winding and connecting procedure carried out. When completed, no matter which opening is placed at the top of the view along the shaft, the windings and commutator sector for the wire connections will be identical. 3-pole motors. The winding arrangement is slightly different for motors which have 3 poles, or multiples of 3 poles such as 6, 9, 12, etc. poles. For the very simple 3-pole motors, the armature looks like this. And with this style of armature, the winds are around the 3 arms, like this. And as before, the commutator sectors at the top are duplicated at the bottom, allowing separate input and output circuits for each of the 3 coils. The windings have many turns, filling the available space, and each winding is connected to the slip ring sector directly opposite it, like this. The start of each winding is connected to the commutator slip ring sector at the top of the armature, and the finish is connected to the slip ring sector directly below it, that is, the sector which is at the same angle as the top one where the start of the wire is connected. This allows the brushes which press against the slip ring sectors to connect to both ends of each coil in turn as the armature rotates. 3-pole motors are particularly powerful, and motors with 6 poles can be rewound with pairs of adjacent sectors amalgamated to give 3 larger sectors. 9-pole motors can have 3 adjacent sectors wound as a single coil to provide the same effect as a 3-pole motor, and 12-pole motors can have 4 adjacent sectors wound as a single coil. The positioning of the brushes is important. With the 3-pole and 5-pole arrangements, the brushes are aligned with the gaps between the magnets which surround the armature. However, the rewound motor can be tuned for improved torque and reduced drive current by adapting the motor housing to allow some adjustment of the position of the brush and commutator slip rings relative to the coils. This adjustment need only be slight, as the angular movement of the brushes will be small. It is, of course, essential that the upper and lower adjusted positions move by exactly the same angular amount so that every upper commutator slip ring sector remains exactly above its corresponding lower slip ring sector. In other words, the commutator slip ring sector at the top and bottom of each coil must be exactly aligned vertically so that the electrical connections are made and broken at exactly the same instant. The commutator and brush arrangement are shown here in UF politics diagrams. The commutator brush marked G, for generator, takes away the energy stored in each coil and passes it to an electrical load. The commutator brush marked M, for motor, feeds energy into the coil from the battery which is driving the motor. The red and blue stripes surrounding the armature are 2 permanent magnets. The magnet shown in red has its south pole facing the armature, and the magnet shown in blue has its north pole facing the armature. This creates a magnetic field flowing horizontally across the armature. The 5-pole arrangement is like this. Here, the designation R/S stands for Radio Shack, which is a chain of stores in America. In the forum, that is sometimes changed to Rs and should not be confused with the large electronics outlet Radio Spares, whose trademark is Rs. UF Politics has suggested that the cheap 5-pole DC motor available from Radio Shack should be used by experimenters to become familiar with rewinding DC motor coils. Being a cheap product, those motors do not have a particularly high build quality, but they are suitable motors for experiments. Forum members share the details of how they dealt with adapting these and other motors. I have to admit that motor windings and operation tend to confuse me, and I sometimes find it difficult to understand what UF Politics means when he talks about different winding strategies. However, it seems reasonably clear at this early stage of forum development, that his objective is to produce 2 things. 1. A very powerful electric motor which can be used in serious forms of road transport as well as for other practical applications, and 2. A powerful motor/generator combination which can produce useful generated electrical power. While UF Politics is very patiently going through many of the possible variations on how a DC motor can be wound and connected, and showing various forum members where they have failed to get some of their windings positioned correctly, he has also shown some of the best ways of connecting a rewound motor used as a driver or prime mover, as some people like to call it, and a rewound motor, which is to be used as an electrical generator. He shows 2 important ways for making a very effective motor/generator combination, as shown here. It needs to be realized that these arrangements are not conventional arrangements and that the rewound motors operate in a different way to motors bought off the shelf. For this reason, it is necessary to isolate the electrical output to prevent current flowing through the load from affecting the operation of the motor/generator combination. This can be done by placing a diode in each of the output lines and charging a capacitor bank, which is then used to feed whatever load is to powered. If my understanding is correct, then feeding any cold electricity produced into a capacitor causes the current to become conventional hot electricity. It is not clear if that action is part of this arrangement, although the circuitry shown should be used. This is the second version. UF Politics comments on these arrangements as follows: as we excite the input of the motor, the generator will start producing energy, and that additional energy will flow through the motor output side because they are connected in series here. 2 rectifiers must be connected at both output terminals, positive and negative, to avoid backflow from closing the circuit through the load. As the motor accelerates, the generator boosts the energy flow which then runs through the motor augmenting the output fields, and when the output is loaded then an engagement of both machines occurs as they start to compensate each other through their output flows. It should be understood that the output should be capacitor banked in a dedicated reservoir. When designing a generator for a specific, existing asymmetric motor machine, it must be understood that generator interactions should be considered to run as counter-rotation to the motor machine's originally conceived rotation, which is easily done by just moving brush lines passing stator bisector angles to the opposite of those needed for a motor, or alternatively, setting the timing backwards. This will definitively enhance the assisted rotation of both machines when connected together in this face-to-face mode. As I do not find the forum comments easy to understand, I recommend that you visit the forum and read the posts, as you may well understand the conversations easier to follow than I do. On the forum, Sanskara316 states, I have rewound a small 3-volt 3-pole motor. I used an almost dead 6-volt sealed lead-acid battery to power the motor. This battery just sits at around 4 volts, and if given a load, even a small lead, its voltage drops to 1 volt. The rewound motor started very slowly, barely spinning, then after a minute or two it started to spin faster, and I noticed that the voltage on the battery was slowly climbing. I connected a small LED flashlight to the generating side and it lit up. Now the battery voltage under load is around 2+ volts. It's been running for an hour now and the machine squeals a lot. It is conditioning the battery and the meter cannot be showing what really is happening. The motor draws 300 mAh. That's not possible as the battery just doesn't have that power. To which UF Politics remarks, well, I am glad you have witnessed some of the effects. These rewound motors do recondition batteries. Remember, radiant energy is taking over the machine, so radiant energy comes out through the input also, which is the reason why we get high volts amps reading on a meter. These motors use very small amounts of current and volts. Inside the motor, every coil is being self-electromagnetically pulsed because they auto-disconnect from the power source. Then the next coil in the sequence is assisted by the first coil when it has rotated to its next position, and so on. The commutator switching has become a self-oscillator for every independently energized coil. Another forum member, Process Hero, says, I have also replicated the battery charging events that Sanskara316 indicated. I started with a 12-volt 4-amp-hour battery which I had been using with another circuit 2 weeks ago and had not recharged it after using it for hours. It was sitting at 12.40 volts. I took my best running rewound motor, plugged it in direct and ran it. The battery voltage dropped to 12.24 volts and stayed at that level for 30 seconds. The battery voltage then started to rise 1/100 of a volt per minute. When it was at 12.27 volts, I disconnected the motor. The total runtime was less than 5 minutes. I then let it rest for 5 minutes. At the end of the 5 minutes, the battery voltage had risen to 12.43 volts and is still at that voltage now. Just think what a larger motor would do on a big battery bank. Everybody needs to document this test as it proves what UF Politics said. New DC motors, and particularly cheap motors, will have brushes which do not mate cleanly with the commutator slip ring sectors, and so, when the modification has been made, running the motor for some time allows the brushes to wear in, and that raises the efficiency of the electrical connections, which in turn, improves the performance of the motor. If you wish to build and test one of these motors, then you can find help and support in the forum with your questions answered and numerous videos and photographs from different experimenters to help you. The Infinity SAV motor/generator. A motor/generator which demonstrates clearly that it outputs substantial power as well as generating its own input power is seen operating at https://www.youtube.com/watch. I certainly don't understand their statement that spinning a magnet past a coil does not produce a force which opposes the passing magnet. However, if this South Korean video is genuine, and it certainly seems to be, then it is a most encouraging step forward. This particular design has 25 rows of 10 neodymium magnets spinning past 250 bifilar coils of wire, and it is demonstrated powering itself while lighting 100 bulbs, driving a fan and operating a heater. Their website now offers ready-made free energy generators at https://infinitysavcom/magnetic generator/. The homopolar or N machine. This device was the brainchild of Michael Faraday in 1831 and has an intriguing method of operation and a remarkably large output. The principle of operation is incredibly simple. If a copper disc is rotated in a magnetic field, then power is developed between the shaft and the outer edge, or any intermediate position. It was then found that the device will still operate even if the magnet is attached to the copper disc and rotates with it, not something which is intuitively obvious. The power output is tremendous, with the capability of extracting 1000 amps but at a low voltage of less than 1 volt. The power take-off can be from one face of the disc near the shaft rather than having to have a copper shaft integral with the copper disc. This device also works with a magnet just attached to the copper disc and rotating with it. This looks like a very viable starting point to develop a device which can run itself and provide useful additional output, since a motor to rotate the disc will not require anything remotely like 1000A to drive it. The snag is, it is very difficult to provide reliable sliding contacts capable of handling large currents for extended periods of time. The second picture above shows the disc with its outer edge immersed in a bath of mercury. This is sufficient for a brief demonstration at low power but not realistic for a serious working device. It might just be possible to get a reasonable working device by accepting that the current output is not going to be anything like 1000A. Long-life brushes could be made from solid copper bar and spring-loaded against the copper disc in matching pairs so that the brush thrusts oppose each other and so do not generate a sideways load. These could be made in multiple sets for each disc, say 4 or 8 per disc, so that the effective electrical resistance between the brushes and the disc is reduced and the possible current draw increased. Similar multiple brushes could be applied to the central shaft cylinder. Multiple discs could then be mounted on a non-conducting, non-magnetic shaft and their brushes wired in series as shown, to raise the output voltage. It is said that in India, Professor Tiwari used homopolar generators to extract hydrogen from water and that bus services were run on hydrogen as the fuel, but I have not managed to find confirmation of that. The main difficulty in using the design is the difficulty in drawing off the very high low voltage currents produced without creating a major drag factor, which is a serious problem. Bruce De Palma managed to overcome this problem, but he assigned his development to the US military in 1987. 3 of the Borderlands science team, Michael No, Peter Lindemann, and Chris Carson experimented with the homopolar design and found that a much more satisfactory version could be produced. Their version produces sawtooth AC instead of DC, and so the output could be fed directly into a step-up transformer. Their design has 4 ferrite magnets glued between 2 metal discs, and, for additional mechanical strength, copper wire wound around the outer edges of the magnets in order to prevent magnets flying outwards if the glue bond should fail. Their arrangement is like this. This appears to contradict the laws of conventional electricity, as there is a very low resistance short circuit directly across the brushes which pick up the AC voltage output. The output current from a small prototype was estimated at 100 amps. The frequency of the AC is directly proportional to the shaft speed of the motor, but the output voltage was almost independent of the shaft speed of the motor, increasing only very slightly with much greater speed. It was also found that putting the brushes at 90 degrees apart on the metal shaft of the motor gave the same output in spite of the contacts nearly touching each other. This design appears to have considerable potential for construction in a larger size and further investigation. While the operation of these devices looks impossible at first glance, it needs to be understood that copper has some very unusual characteristics when interacting with magnetic fields. This is explained in the website http://magnetism.vftech.com/spinningcylinder.htm, where it can be seen that a spinning copper cylinder exerts a large sideways force on a permanent magnet placed near it. This does not happen with spinning cylinders made from other metals. Nikola Tesla took Faraday's 1831 design further, as can be seen from his 1889 U.S. patent number 406968. He remarked that to get any kind of useful power from the device would require a copper disc of very large diameter, or a disc which is spun very fast. A large copper disc would be an inconvenient size, and a high rate of rotation makes it very difficult to get a good, long-lasting, sliding contact at the outside edge of the disc. He also pointed out that current flowed from the shaft out to the outside edge if the magnetic field passing through the disc was in one direction, but if the direction of the magnetic field were reversed, then the current flow would be from the outer edge inwards to the shaft. The same change of direction of the current flow also happens if the direction of rotation of the disc is reversed. Using those facts and considerable ingenuity, Tesla proposed an arrangement where the power takeoff is from the axle alone, by using two separate copper discs and magnetic fields which moved in opposite directions. This arrangement has the advantage that it has an output voltage which is the sum of the two separate voltages. This basic concept uses four ring-shaped magnets and two discs of copper, brass or iron. Both of the discs are given a wide flange, as shown here. The circuit shown here is broken by the gap between the discs, and Tesla dealt with that by using a flexible metal belt linking the two discs together. While it is possible to use the belt to drive one of the discs, Tesla did not use that method. The belt overcomes the need for a sliding contact at the outside edge of the discs, and so both sliding contacts are at the axles, which is an easy place to have a sliding contact. Tesla shows the contact against the end of the axles as that is just a rotary movement with respect to the stationary contact, but even if the contact pressed against the outer face of the axle, the sliding movement would still be relatively slow. In spite of this clever design from Tesla, I have never heard of anybody building this style of generator in spite of the large currents which it can generate. A developer who prefers to remain anonymous, says, for people who have an interest in homopolar generators of the type experimented with by Tawari, Trombley-Cohn, De Palma and others, what if there were another configuration to the engineering of a homopolar generator than the standard method of running a magnetic field parallel to a rotating shaft and through a conducting spinning disk? Though someone may have formulated this alternate type of a homopolar generator, I have never read nor am I aware of anyone having put forth this idea nor having constructed any such homopolar generator mentioned below. The below design information is public domain information, and so anyone is free to construct a device and or make use of this information however they wish without royalty demands. In principle it is no more complex than the Faraday model. Having made some study of these above-mentioned devices by Tawari and De Palma and learning of some of their shortcomings, I kept wondering why it is that at this point in time, since the coming of the age of neodymium magnets which were not available in their time, no one has considered their use in an alternate configuration. Neodymium magnets can be had in what is termed as arc magnets. These magnets are designed to be mounted on drums or cylinders to serve as poles on a rotor in a motor or generator. The Faraday dynamo or standard homopolar generator was made such that the magnetic field is parallel to the rotating axle through a rotating and conducting disc. With arc magnets we can mount them so that the field is now perpendicular to the axle, in other words on a drum circular about the axle with one magnetic field directed outward and the other inward to the axle. Let us say the north pole is going outwards and the south pole going inwards toward the axle and then curving out of the ends of the drum as shown here in Fig 1. At this point it is interesting to note that the axle is serving as a magnet, and since the south pole is directed out the ends of the drum, the axle itself has become a magnet that has a south pole at each end of the axle. Where the north pole might be in the axle I'll leave to the debating society. A tubular conductor is placed over or under the magnets. The magnets can be difficult to mount in this fashion as they will not want to be mounted that way. The charge, also referenced to as a space charge, will separate to the ends of a conducting tube or copper sheet wrapped over or under the set of magnets, where brushes at the ends can tap the current when the device is rotated. This new arrangement opens up multiple manner of possibility. It can allow for a lengthy drum, the addition of added drum segments of magnet sets which should increase voltage. It should also be possible to mount magnets on the drum that alternate magnetic poles, in common fashion similar to a common motor, and use back and forth wiring over the poles faces to multiple voltage. Of course this cannot be considered homopolar but rather polypolar. The reason for attempting this is to raise voltage to the point that exotic brushes need not be considered as much higher voltages can be achieved. For those not familiar with this form of homopolar generator, the reason for rotating the conductor with the field is to overcome the effect of the counter-electromotive force of the generator or circumvent undesired effect of Lenz's law. While I do not have the machine tools to make a good homopolar generator, I was able to hand make parts that I assembled into a proof of concept generator. I was able to prove to my satisfaction that this tubular type of homopolar generator does work, but I cannot say how well. I have reason to think that it should prove just as valid a method as the standard Faraday dynamo. Anyone with the tools is free to make his own. I would like to learn the outcome of your work. Here are some pictures of my construction. The builder states that in his opinion, the voltage will be increased if the device is built with a longer cylinder containing more magnets, and so the sliding brushes which take off the output current are further apart. He is also of the opinion that if the diameter of the device is increased, that the output voltage will also be increased. He does not have the necessary equipment nor the finance required to develop this further, but he invites you to build this design and take the design further. In my opinion, it should be possible to use ordinary rectangular magnets positioned so that they touch along their inner ends and have a slight gap at the upper face all along their length. It should be possible to mount them securely on a non-magnetic cylinder before wrapping copper sheet around them to form the copper cylinder of the device.